In this video, we discuss the demodulation of FM signals. This is a modulated signal for FM modulation. We have the magnitude of carrier AC, carrier FC, and this is a phi of t. To demodulate the FM signal, we have two-step procedure. Step 1, we want to generate AM signal where the amplitude proportional to the frequency in this FM modulation. And then we're going to use envelope detector because we know envelope detector in conventional AM is very simple circuits like this. We have a diode, we have RC circuit. This is very easy to implement to obtain the envelope of the AM modulation signals. So now, if we understand step 2, we only need to implement the step 1 now. So the answer is quite easy. We take the derivative of the modulated signal. We're going to use this chain rule. If I have cosine gx, and this is any function, and chain rule, I'm going to have minus sine gx, and then you take the derivative of g with respect to x. du dt, using this formula, this is a gx. The whole thing is g. The whole thing is a function of gx. And here is a function of t. Of course, it will be g of t. Okay. AC sine 2 pi fct plus kf, this integral from minus infinity to tm tau. And then we do the derivative of the highlighted yellow portion here. That equals to 2 pi f, right? And plus 2 pi kf. And this portion come from, you take the chain rule, take the derivative of gx minus 2 pi ac fc plus kf mt in sine portion here. Right. This portion, the highlighted portion, what it is, this is the instantaneous frequency in the FM modulation, and the instantaneous frequency in FM modulation always greater than 0. So therefore, using the envelope detector, we can always detect this portion out. Detect this portion with the scalar 2 pi AC. Now, what about this minus sign here? It actually doesn't matter because this is a 2 pi. This is a 2 pi FCT. This is high frequency with FC. FC is the carrier. Remember, this is the input of the demodulator of the envelope detector. So if I have a sine signal like this, right, minus sign, so you're going to reverse, everything just reverse. So this is a T, this is T. If this signal fed into this envelope detector, there's a diode here. And in this period, during this time, the diode is off. But from here, the diode is on. So therefore, but because this is a high frequency, the frequency with FC, so the duration here is very, very small. After that, the envelope detector will detect the envelope. Therefore, it doesn't matter here in this case. Now let's do a little recap. To obtain the message from the FM modulated signal, first we take derivative to generate AM signal, the amplitude proportional to the message that's here. And then we use envelope detector to detect the envelope. We can obtain the message. The diagram. So this is a diagram of the demodulator we just talked about. And this is a U of t. And this is RT received signal that equals U of t. We're assuming ideal transmission. First of all, you take derivative with time, and then you pass through the envelope detector, and then we're going to obtain this portion. This portion is the amplitude of the derivative. There are other methods of demodulation, and we do not discuss here.